What we do in this field is by humans, for humans, and with humans. And I think if you miss that idea, you will not achieve the potential. Remember human.
Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. Hey, hello, everyone, and welcome to a very special live edition of the How AI Happens podcast. We are here on Zoom, on video, live, which begs the question, is it really even a podcast at all? Is it a webinar, a webcast, perhaps a podinar? I don't know. Whatever the parlance is, I am your host, Rob Stevenson, and we're going to have some fun here today. We have assembled a panel of experts with just a ton of experience in our space and the technical know-how that comes with it. And we are going to be chatting with them all about the ML Pulse report. What is the ML Pulse report? Great question, imaginary podinar listener. I will tell you. The Machine Learning Pulse report is published each year by my friends at Sama, and it is the result of surveying thousands of practitioners in our space. This year, the report focuses on the role of generative in those professionals' work, how they are measuring their model effectiveness, how they expect it to impact their work in computer vision. So today, we're going to go through some of the findings of the report. We are going to have our panel react, offer some solutions to the common problems folks are finding. So we know what the ML Pulse report is. Let's get to the goods here and meet our panel. First up is a professor of robotics and electrical engineering and computer science over at the University of Michigan, go Blue. He is also the chief science officer at Voxel51, Jason Corso. Welcome aboard.
Thanks, Rob. It's a pleasure to be here.
Really glad to have you. Did I do your curriculum vitae justice there? Is there anything else you'd like to add so we can get to know you a little bit?
Certainly, yeah. So I guess one bit of background would be that I'm kind of here by accident. As an undergrad, I had a few different types of jobs, database programmer, web designer, researcher, and so on, and just kind of fell into the idea of academic research because I like to build things. And ultimately, after 10, 15 years in that, realized, I can start a company. And that's Voxel51. And it's been a good journey so far. So glad to be here to talk about that journey and the Gen AI revolution.
Was there a moment, like you had this very technical background, but it predates AI in the current way we, I'm sure, think about it. Was there a moment for you when this kind of technology kind of turned your head and you're like, this is where I want to apply my expertise?
Oh, it's a good point. I've been working with computers since I was like 6 years old. The moment that I could make a little sprite bounce across my Commodore 64 screen, I was hooked forever, no matter whether or not it was like hard-coded or AI. I just love the interaction between physical systems, computational systems, and humans. I think it's a great intersection.
I've also been playing with computers since I was 6, but I was not printing Hello World. I think I was playing Math Blaster on Microsoft 95 or whatever it was, Windows 95. So kind of different backgrounds, but here we are talking about all this great stuff in AI and computer vision. Jason, thanks so much for being here. Also waiting in the wings is our other panelist, who is the SVP of AI Products and Technology over at Sama, Duncan Curtis. Duncan, welcome to you as well. How are you today?
Good, thanks, Rob. And yourself?
Really, really well. Thanks for asking. I'm doing great and excited to be doing this live podcast. And I would just love to know a little bit more about you. I kind of just told about your current role, but I would love some background so the folks out there can get to know you as well.
Sure. Engineer by training. I was most recently head of product at Zoox, the autonomous vehicle startup that's acquired by Amazon. Before that, I worked at Google, loved my technology and loved being there, having a huge impact. Before that, the rest of my career is based on video games. So I'm partially to blame if you were a loved one of lost time swiping fruit in Fruit Ninja.
Oh, no kidding. Just thousands and thousands of hours poured into Fruit Ninja, slicing up watermelon and whatnot. I have you to thank for that. We can talk later about all the years you stole from me. But in any case, here we are to talk about generative. And that is kind of what the ML Pulse report was focused on, the role of generative in the workplace, how people anticipate it impacting them. So let's pull up our presentation here just so we can have something to look at besides my mug and background. Before we get into some of the takeaways, maybe it would be worthwhile to sort of limit the conversation. Generative, it is everywhere. The hype is real. but it can refer to lots of different things. So maybe we can point it in one direction. Duncan, would you mind outlining for us, when we just throw the word generative out for our purposes, what are we talking about here today?
Absolutely. So obviously there are a lot of different technologies, similar technologies, close to each other technologies. And so what we've done for ease of communication is that we typically group, whether you're talking about like LLMs, generative CV, whether you're talking about foundation models, we kind of lump them into generative AI just so that we can have a more easy flowing conversation. Obviously, I think Jason and I will call out specific subsections as it makes sense relative to it, but that's generally where we go with it.
Gotcha. Okay, that's helpful. So this first slide and this first response, I guess, shouldn't surprise anyone. 74% of respondents say Gen AI is worth the hype. Yeah, it's everywhere. Again, I guess maybe could have expected that. I guess first, maybe Jason, where would you answer this question? Would you agree with the 74% or where do you come down?
Yeah, it's hard to answer with one clear answer. So, I think the respondents must have felt the pain that I feel, because I think on the one hand, sure, right? I mean, we're seeing capabilities that are like easily available through simple APIs, accessible to startup teams, to enterprise teams, to students, to hobbyists. Like, I'm sure there will be new advances. Even if we just pause quickly, thinking like code copilots, that alone, great, like fabulous advances. However, I think there's also a like good enough hesitation to wonder like, what is the limitation of Gen AI, right? Like, in computer graphics, there was so much hype 20, 30 years ago about like being able to generate like really photorealistic images, video frames, and so on. And then we learned about this notion of an uncanny valley, right? Like, we can get so good, just so good that we know that they're still cartoon or computer generated. And then to get to like actual photorealism, we don't really know how to cross that chasm, right? So we kind of, in like special effects movies, that gets hidden quickly, like fast moving sequences and so on. So you can't actually focus on it. I don't think we have a good sense for Gen AI, like where that boundary is. And I don't know when we'll find that out. In fact, I don't know what you think, Duncan, but that's like, that's my biggest hesitation about it.
No, I completely agree. I would agree with you, especially on the like, is it worth the hype? Yeah. I mean, there's definitely some transformative technologies that have come out of it that are already here and they're now part of our ecosystem. And I think you touched on it briefly, Jason, is I think one of the biggest advances that we had with Gen AI is the accessibility. And it's something where we haven't had that level of accessibility for new technologies, certainly ones that are highly advanced, in a very long time. I remember my head of user research, Claudel, her grandmother asked her about generative AI and started using it. And that's when she was like, oh, wow, that's so accessible that my grandma, who has trouble with social media and where do I click the buttons, was like deep into conversations with ChatGPT and learning about it in those ways. But so I think that hype has been really valued and really valuable. The question is the hype about what else we can apply it to and in what ways and when is it going to have real business value and business impact? That's like Jason, I think that there's some pretty big questions there. I would also ask, like, well, one of the ways I think about it is how much of what we're going to see out of Gen AI are we already seeing? And so how much further do we have to push it? And I think obviously adopting it to new use cases is great, more distribution of an existing technology, as opposed to like, well, what else are we going to be doing? Especially as Jason pointed out, that like uncanny valley element. We've also got the fact that, what's the business impact of a hallucination? Maybe it's fine if you're like just asking ChatGPT about, how to make a recipe and the recipe goes wrong, not really a massive impact for you. But if you're relying on it as a core differentiator for your product and your business, what's that user impact of those kinds of elements?
It is curious that no one outright in the survey said no. No one was like, it's all a bunch of hooey, which I guess speaks to the overwhelming, the majority here on board with it. But for the folks who are like in the not sure camp, I want to hear from y'all. Like, put yourself in their shoes. What sort of hesitation do you think one could have if they're like, I'm not totally sold yet?
Yeah, I mean, if I had to think about that angle, I'd probably pin it on the like general versus specific versus sort of personal access, right? Like, I mean, I could use ChatGPT or some, Bard or whatever to go and interact with it and ask it questions about research or general topics like my kids are in high school history or whatever, right? Like we can go and talk about certain things like that. However, it can't help me figure out the best way to approach I don't know, like I have a plumbing leak or whatever. I think like that's not specific enough to my own house or my own need or something like that. Maybe there's a little bit of hesitation around like, what about me and how can it be personalized for my own needs? Perhaps that's one angle that comes to mind.
Yeah, I would build upon that and even take the business angle and say, like, there are use cases that people are developing traditional AI for that it doesn't make sense that generative AI isn't necessarily useful for that use case. If I think about, oh, great, generative AI could create interesting text and do research, or it could create interesting images, that doesn't drive a car. And so, if you look at those kinds of use cases that we see within AI, it's not necessarily a good fit for those cases. And there's also, I would argue, when you talk about the hype level, is that the pressure to have generative AI everything is huge. It's absolutely phenomenal because everyone understands it is the hotness right now, which is, it's great when the use cases make sense for it and that you can drive real business value. But then you also have to have the other side of it is with generative AI, unless you own your instance or you've actually doing like a fine-tuned model, which means that you've got to create a fair swath of data in order to do it, is it any different than what your competitors can do? And in things like no code or coding assistants like Copilot, those can be really useful just to get that acceleration of development speed, but it's not necessarily a massive differentiator for you.
Yeah, actually, on that point, Duncan, so I actually had in my notes, I definitely wanted to talk about like cloud versus local, because I think this is related to the potential value, and like it's the same thing in some sense as like general versus specific. In order to get specific, either you have to like, I guess you can deploy that in the cloud now with OpenAI's new like custom model customization. But so just a concrete example, I work on a project that's funded by DARPA at the university, and it's all about building AI assistants that can kind of see the world that you're seeing. And you wear a head-mounted display, and it can guide you through steps, like if you are cooking a dish or whatever, or fixing an engine, which is one of the more realistic use cases. Like you're about to use the wrong tool, well, the AI assistant can like tell you, pause, wait a second, Jason. You're supposed to use the pliers here, not the screwdriver or whatever. And so we had this big demo last week on site. And we use one of the public APIs for LLMs for this, mostly as help with reasoning, right? Like we kind of like do some inferences about what's happening in the scene, and then go and like ask for general reasoning capabilities to really understand what's happening and whether or not we should interact with the user. And the API was down the whole time, like the whole morning, right? So because we didn't have enough time to pull a model locally, just in terms of training. So I think maybe there's that angle as well, right? Like, how do I customize one of the publicly commercial available ones, or should I go use one of the open source ones, right? Like Lava or MiniGPT or whatever, right? Like I think those are big questions that maybe don't talk too much about the hype, because I think still people are still on board. Like, okay, we're going to move in this direction, but the practicality of it, I think, is still a big unknown right now.
I would agree. And even I remember in the earlier days of generative AI, just even a few months ago, so we're starting to have real questions around, well, who owns what's happening? Like if I'm using a ChatGPT, we saw everyone wanting to use ChatGPT or Bard or different coding assistants. And the question started coming up like, wait, who owns the code that's written with this assistance? And you start to get into all these interesting business use cases where you're like, hey, it's great that it helps, but is this something we can deploy at scale for customers, or is it something that we own? Is it part of our core IP as a business? Which I think is also something that we're still very much working out. Really interesting space, a lot of really fun, interesting problems to like get your head around, like, what's the right business model to get adoption. For example, if you look at something like Ironclad's a really good example for legal document processing. They've basically got their own instance where you pay a fee because that way your data is not being used to train models, and you own the IP at the end. And that's basically a service that you're now paying for. But it's another one of those practicality examples that you're mentioning.
What are some of the other use cases you foresee? Jason, maybe we'll start with you here, particularly if you were to keep it in the field of computer vision.
For Gen AI, so let's see. It's the way I think about computer vision, and probably a lot of like AI system development. I like the word AI system to be sort of like the collective, right? Like the code, the model architecture, the data. I think when you're engineering or developing these systems, right, it's kind of like a loop, right? Like you do some work with data, you do some work with models and with code, and then you do some analysis. And like the faster you can iterate through that loop, the better off you are, right? Like in some sense, like at Voxel, my company Voxel51, like our software is an infrastructure to help iterate through that loop as fast as possible. How can Gen AI feed into that loop, right? Like, well, on the data side, there's the obvious value of like actually generating samples that are useful. But the key is, how do you know what samples will be useful, right? Like without the like model work and then some analysis you do after that, like you're just walking in a dark hallway. So you're just kind of generating, like using DALL-E 3 or something like that to generate images that are like some other ones you have. But like if you know and you can kind of prompt like the current and future Gen AI systems based on like embeddings. Okay, I want you to generate me distributions of samples that are like this distribution in the embedding space. That would greatly reduce the burden on the data engineer as part of this like data model analysis loop. Like that's a surefire win that goes there. Maybe one other, and then I'll hand it over to Duncan. Perhaps like on like the model and like the analysis side, I was invited at the Midas Center at Michigan a few weeks ago to participate in this, like, how is Gen AI revolutionizing experimentation? I unfortunately couldn't give a talk because I was busy at the time, but like all these talks were all about how do you use basically like set up in context learning with pre-trained kind of general, LLMs to propose new experimentation setups based on questions you have that are written at a high level natural language level, and yet rendered down into ideas that are asking questions at like a scientific analysis level that maybe you didn't consider. And the fact that it can kind of output your Python code or your Rust code to go do that for you, like, or at least like a first iteration of that, really speeds up the work.
Absolutely. I was actually going to give a shout out to you also on the Voxel side, was that being able to use it to create synthetic data and to augment your data sets is amazing, but you do need those other elements, sort of, whether you're calculating embeddings, looking at the embedding space, at the distribution, but you also need to understand, where's my model performing right now? And so if you've got, one of the things we do with clients is looking at, like, given your model predictions, where are you right and where are you wrong? And then you can also dig in from a data engineer perspective and look at, okay, well, this is more of what I need in my data set in order to, try to correct where my model may not be performing yet. But once you've got that insight, being able to create synthetic data is a fantastic way to be able to like broaden the distribution of your data. But it's also really useful for edge cases where you're like, hey, I haven't got a lot of instances in my data set, but I've got a couple and I can describe in a natural language way the other things that I'm looking for. And so that can be a really interesting way to approach it.
Yeah, synthetic data feels like a huge opportunity. I spoke with the founder of a company called Agrisynth recently, Colin Herbert, and they're using computer vision to identify specific types of crops. So the input, they're training it on actual imagery, like photos that have been taken for like the human eye. Like it's data that was collected for humans. Machines don't see the same as humans. So the input is like a photo you or I might take, but then the output is just like beautiful, multicolor tie-dye sort of thing. It doesn't look like a plant at all to me, but to a machine it does. And that felt like a huge breakthrough that like, oh, well, let's make data that considers how a machine sees pixel by pixel all the way across an image, as opposed to how you or I might aesthetically, holistically in terms of a photo. And so that is all using the computer vision, like training with images, computer vision output is this synthetic data. Fantastically brilliant use case I came across recently. So
I will mention that, as we were talking about before, the idea that it's great as a synthetic data generation tool, but you still need to check that it's producing what you asked it to do and that it's the right kind of thing. So having that feedback loop, that human in the loop sort of feedback loop, is one of the areas that we've seen that is still very much needed there to at least sample the synthetic data that's created to make sure that you're not like going off on a different path.
Yeah, I mean, actually, I'll chime in on that point as well, and like take that as a segue to some other thing I wanted to mention. So indeed, right, like it generates output that's interpretable by humans, right? Like period. Not all of it, not always, but like many of these, the notion of gen in the expression is that. But I would think of that even as less abstract a little bit more, right? It's almost like it has a democratizing effect on like how and who can do this type of work, right? If I could be so bold as to make a prediction in robotics, I feel that I have been in for a decade or so now. Like one big problem is semantic mapping, right? Like you have robots that can move around in environments, and robot knows about like the metric space, like it's using some sort of occupancy grid or some other representation of the environment. And it doesn't sort of speak language. It speaks metric. It speaks like what it can see and how it can render that into free space to move. Same thing with autonomous vehicles, for example. Humans don't speak that language at all, really. Not even like robotics engineers, right? They're always trying to figure out what are ways in which I can like get the robot to do what I want it to do, but I don't really know if I have the right factor graph or whatever to do that. I would probably argue that one of the next waves we'll start to see is like right now, how that bridge is made is through like semantic categories like door and barrier and garbage can. This is kind of like programming with a 64K memory buffer like we were 30 years ago, right? Like not really that effective. What is effective is natural language, right? Like how I talk to my kids or how, frankly, I even talk to my dog, who's probably smarter than most of those semantic mapping robots, right? Like, so I think that we'll start to see like the ability to use language generation and even like non-language, but semantically meaningful generation, like imagery or whatever, as a mechanism to translate between different languages, like robotic metric mapping and human speak, is at a beachhead stage right now, like just the beginning, I would argue.
Is there a version of language in the middle of those two things, of human language and the way that a machine would understand language, for example? So when I think of the way you write a Google search, restaurant near me, right? And Google knows what I want and it gives me information. I've learned to speak to that machine in a way. If I marched up to you and said that, you'd be like, "Are you okay, Rob? Are you like having a stroke? Do you smell toast?" So is there like a middle of the road, like a pigeon sort of version of language? Or do you suspect, Jason, that like with large language models, it will just be natural language processing? I can speak to it like I would anyone and not have to adjust my parlance at all.
Yeah, I would probably deflect it to say that in most of these approaches, there's some notion of a latent space, right? A space that we don't directly observe. It's not the language itself, or it's not the data, the sensorial data that we input. It's like, I called it embeddings before, but it doesn't have to be like concrete vector embeddings, but there is some latent space that is present. Whether or not there's one, like the capital THE, the latent space, I don't know. I don't think anyone really knows, but like it's common. And that's why we've seen like an explosion of vector DB companies in the last, I don't know, 5-6 months, right? Like, and I think the way I would think of it, at least in the short term, would be that one can take, as long as you can sample that latent space, you can take projections of it and map that to whatever other space you want, right? Like human language or robot metric space or whatever. So I'd probably argue, like, I don't think it's a pigeon language that we would need to understand or whatever, but there's definitely some representation that is the translation representation. And I think it's probably the embedding space or the latent space.
And then for more like just for general like chat interfaces, is where you're talking about, whether you got the chat GPTs or Bard, is that one of the things that's interesting, you gave the example of like, oh, I would Google, restaurant near me. And the funny thing is that we're already seeing the prompt engineering where people are becoming actually like, so talk to me like you're a X, like you're an expert, scientist, or you're a roboticist, and then go do these other things so that it has context for how it wants to respond to you. So I'd argue that while there is a really nice layer that it's giving us for NLP, so you can naturally talk and naturally understand things, I think the way humans are going to interact with it in a lot of different cases is still going to have this different version of the pigeon speak equivalent where you're like, hey, this is how you should interact with it to get what you want.
Gentlemen, I could speak about latent space with you till the cows come on, but at a certain point here, we should keep going with the report because there's lots more to get to here, but I do appreciate your satisfying my curiosity on that point. We have another takeaway here I wanted to share, which is all about some of the challenges that people are facing, particularly in computer vision for machine learning engineers over the next year. That said, on the left there is sort of separate from the question on the right. But first of all, 65% of respondents not being confident their models will survive in production. I was struck by this, seemed high to me, but is that just as engineering? Is that just like, oh, let's see if it works? Like at a certain point, you have to go from training into production and see what happens? Or is that number kind of consistent what y'all see out there in the market? Or is this particularly high given the industry we're in?
I love this number. I think this is honesty at its core. I'm really glad the number is not like 10% or at 5%, because most models don't work, especially not first iterations of models. Again, going back to this like data model analysis loop, right? Like, first of all, models don't get trained once, get deployed, and then live forever and ever and ever. They have to go and get adapted on the fly and updated over time. So like, it's a little unclear. This sentence answer is almost like saying to me, Is it the initial one that's not going to work? Definitely. That should be 99% then, because no initial model. Or is it the one when the engineers say it's ready to work? Probably that should be like 80% then. Or is it the one when it's like the tension between the business and the marketing team and the engineers come together and they're like, okay, look, guys, we got to deploy now. And that might be the right number there, right? Mostly because like it's hard to build data sets. Like it's one thing to build models, right? Like models we have a lot of algorithms, a lot of machinery. That's what we're trained in school. But there's like limited training about how to build a good data set to go and train that model, right? Like it's really like, I don't think of it as a chain, right? Like it's not go do your data work, then go do your model work, and then deploy your model. It's really like a loop or like a random walk. I wrote a blog maybe a couple months back, like the machine learning random walk, where it's really like this co-development of your data set alongside your model. You might have a few different models at the same time, and even a few different projections or subsets of your data that you care about. And like you are building these things together. That's why like the work that Sama does, this data work is so critical so that we can appreciate the need to go and build a data set that has the same distribution as the distribution that we want to see in practice. Unfortunately, the in practice part is seldom what we measurable in the lab, right? It's always a little bit different, right? That's why like I'm so glad we've made so much progress, even in like AI or even non-AI things like in video games, because like it's hard to understand how users will use your system. We've learned that with 51 forever. And it's just a constant lesson that we learn. And I think this is just a situation where in practice, you'll do a great job with the data you have or the prior data you have and the information you have to go build your initial data set, your initial model. But unless you iterate in the field, in practice, many times until you truly appreciate the fact that at the moment of deployment, you mirror that distribution, you can predict how your model will perform. Also recognizing that the next week it's going to change a little bit. It's really hard to know how well your model is going to do. And in my experience, like at Voxel, like we don't build our own models really. We're an infrastructure company, but we talk to tons of companies and users that build models. So we hear these challenges all the time. And I think there's a lot of pressure to go release models before they're ready and fully tested.
Absolutely echo that. And I'd add to it and say that I think it's also a maturity of our industry where putting models into production there's a process. As Jason was saying, you don't stop and you're never done. I mean, a lot of the software, like the traditional software industry, there are people that I work with that are supporting a version of their code that's a library that's 20 years old, that's just sitting in some system that's still just chugging away. And that's really different for AI, where not only is what you had when you did your initial data collection potentially not true, but the world also changes for a lot of use cases. Sure, in some like really controlled environments, like maybe a manufacturing warehouse, you might be able, or a manufacturing line, you might be able to keep the noise of change relatively low. But that's not true if you start doing new products or new different lines and things that look different, or someone changes the lighting. So this idea that your model is never really done, we need to move to this concept of get it to production. Great, it's doing pretty well. We've got an idea against the data we collected, but this is never really going to end. And I don't think the industry is there yet from a maturity standard to understand that that's just part of AI development. And there's tool chains that we can set up in order to actually manage that.
Definitely agree, Duncan. In fact, anecdotally, one thing that comes to mind, and this is maybe even getting back to the hype notion, is that to actually field production systems, you need 99.x% performance, right? Like the fact that your system misses on 3 out of 100 cases, 97% performance, is great to publish a paper, but it's not actually good enough to field a system. That could mean, I don't know, like in surgical systems, right? That could mean a sliced vein or something like that. Or like in automotive industry, that could mean even a near miss from a bicyclist is dangerous, because that might make the bicyclist do something crazy and go crash and hurt a kid or something like that, right? So like, I think that the level of performance is really high that's needed to field real systems. And if you look back at like just even 20 years ago, what's one of the first computer vision systems that was fielded? I can think of 2, right? Like one is the automatic face detection in like handheld cameras. And they used that like where that face was to autofocus, like really great use, because if it failed, the user could just touch the screen to where they wanted to focus. Like it was an easy out. The second one I could think of is the first down marker in the broadcast television for college and professional football. I don't know. I think it works most of the time, but there's someone sitting in a trailer that turns it off, as far as I know, that turns it off when it's doing something weird and just going to ruin the broadcast. And that's why there's a couple second delay in live broadcast. So right, making things work really well requires a lot of attention to performance, or you got to set up the system or structure in a way that it is a human in the loop, so that like during the actual deployment in some effective way. Those are the systems I've seen that work the best.
We had an interesting use case or one from my past. It was an interesting, like maybe easy to understand example as well, is that about self-driving cars. About maybe 5 or 6 years ago, we started seeing these like line scooters, the electric scooters, especially I'm in San Francisco. And so they just started showing up everywhere. Before that, all the data collection, skateboards, great. Pedestrians, great. Which one of them is this? And by the way, an electric scooter, so you could identify that, look, it's a vertical human on a flat surface. Yeah, there's a little bar in the middle, but you could pretty accurately say, hey, whether it would get captured by that idea. But when you're flagging it as a skateboarder, that comes with a whole load of assumptions around what's its top velocity? How's it going to behave? And an electric scooter can do 35, 40 miles an hour compared to a skateboarder. And so it can be really different. Whereas, as Jason was mentioning, having like a human in the loop to proactively find these edge cases as the world changes means that you can go and collect new data or find data that you've been seeing in production, annotate it differently, get your model to understand it, give it a new behavior class in that case. So you're like, oh, scooters actually act like this. And then you can redeploy it relatively quickly before it's a major issue.
Having a human in the loop to identify the behavior class of how radical something is, I think is useful here, right? Oh, it's a skateboard. Okay, much more rad. But to the point of models, Paul Valery once said that no poem is ever finished, only abandoned. Perhaps it's the same with models. And this number, 65%, as you called out earlier, Jason, that is encouraging. I think folks seeing that should be like, okay, it's not just me, right? This is a normal part of the production cycle. If you are like, I don't know if this is going to work, yeah, good. It's you and everyone else. So don't panic if that's where you sit. Related to this stat was some information that we gathered just on all of the challenges people anticipate facing. And this was sort of a check all that apply situation. And we have to report here that for ML engineers in computer vision, you're in for a world of hurt because these are all the challenges people are seeing coming down the pipeline. We kind of stack ranked them here. And so I was hoping our panel could maybe pick one of the top 3 here and offer some solutions for it. So they are the number one challenge people anticipate is turning requirements into solutions at 61%. Below that, collecting and generating data, of course, evergreen problem, and then debugging and detecting errors in their data, 52% report being concerned about that. So Duncan, we can start with you. Would you just want to pick whichever one you like and offer a solution, and then we can go from there?
Right. Argue debugging and detecting errors in the data is, I'm going to give a shout out to Jason and Voxel, where finding the right tooling to help you be able to understand your data, whether it's calculating the embeddings and looking for the distribution space or being able to visually pass through your data much more quickly. We actually have an instance internally and it's been super useful for us. And so in terms of what might you do about these challenges is looking at your tooling to understand your data. How do you identify outliers early? How do you look at some of the things we see commonly is the camera, let's say we get a range of images and the camera shutter just didn't match this time. So you just get a black image. Not useful for us to label in that case. So how do we pull that out of a data set and flag it for customers to decide what they want to do with it? So I'd say that with debugging and detecting errors in your data, I would definitely say look at some of the tooling that can enable you to move more quickly and understand your data better.
Great. I appreciate that, Duncan. And we totally dig it, man. Especially this notion of debugging your data. There's no category that defines the 51 or 51 teams tool that we launched a few years ago. For a long time, I was this staunch advocate internally for 51 as a data set debugger. Data debugger. It just never, the marketing folks felt like it would fall flat. So marketing is harder than AI, I think. But if I had to go and I could take the first one, right? Turning requirements into solutions. I think this is one of the hardest parts of really, most engineering work, right? There's this quip in research that says the first 90% or it takes 90 minutes to choose the right problem. And then it takes another 90 minutes to solve that problem or something like that, right? Choosing the right problem is hard. And I think this is as equally the same for AI systems, right? Even just what is the ontology or the taxonomy that you need to get annotated for? First of all, what data do you need based on your problem requirements? That alone is a hard problem. Then you got the raw media. how do you convert that raw media into something you can use to get annotated, to build a model on, to test a model on, and so on? Like, one thing that came up that bit one of the teams I was working with in the past, in the bud for a while, was the notion of groups, right? Like, okay, do I annotate individual people, or do I annotate small groups, or whole crowds of people, right? Like, where do I draw the line, and what do I need for my own work, right? So like, I think that is a big deal, like creating the right sort of semantic space. And I think there are two axes of solutions, which is where one is work with experts. That's important. Like, people, there's no replacement for a good experience when it comes to actually boxing in a problem, especially in AI. I've talked with Jerome for quite a few times, like in different vectors in this space, how do you define different ontologies or different sets of groups and so on? Like, the wisdom of experience goes a long way in requirements into solutions for AI, for sure. But I do think on the second, like on the other angle of a problem would be that I think that Gen AI has some insights here that we haven't yet figured out how to tap. But I have the sense, my intuition says we could learn a lot by the summary type of analysis that these LLM models have done, especially now that we see like vision plus LLM models coming out, whether or not they're, again, commercial or private or public open source. I think we'll figure out the right way to prompt them or in context query them to get better insights about how to do requirement generation for AI in the coming months or quarters.
Yeah, and I'd also mention Gen AI is a great way to get started. I talk about some of the problems with synthetic data and how you want to check it. Often in that early development stage where you're just like, hey, I've got an idea and I think I have an idea of how I might solve it. Just getting that feedback loops smaller and smaller and faster, like, it's a great way to get started. You can generate a few thousand instances of synthetic data that moves kind of in the direction you want before you really even understand the problem to the depth you need. But it can get you there and show like, hey, are you on the right path? Or is this maybe you need to take a different direction?
Yeah, really helpful. Thanks, guys. Moving on, one of the report I wanted to pull out is how folks are measuring success and measuring the effectiveness, accuracy of their models, et cetera. And so I was hoping we could pull out some of these and understand from you two if this is what you look at as well. Maybe there's something people are missing. And so obviously, one of the most reported at 30% was user satisfaction. If you don't have satisfied users, you're not shipping a lot of products, right? So that as a true north makes a lot of sense. The most popular, though, was standard quantitative model metrics, precision accuracy, et cetera. So I was maybe living in that 43.5%, I can ask you, Jason, to start with some of your standard quantitative model metrics, because when you get into reporting and metrics, there are the ones that are the vanity things. There are the ones that are maybe not really telling the whole story, the ones that look good on a slide deck, but maybe aren't actually helpful to the model. So can we start with just what are you looking at when you're trying to measure success?
Yeah, it's a great question, Rob. So I think the notion of what's the right benchmark and how do I measure my model performance against that benchmark has helped move the computer vision community or industry a long way in the last couple decades. When I was starting as a grad student, a custom few dozen images and some qualitative pointers with good visual analysis, and even going back 20 years before that, actually, I teach a Foundations of Computer Vision course where we weekly read a seminal paper from the 80s or the early 90s or whatever, the Gieman paper. I don't know if it's one of the seminal papers of Markov random fields, has something like 15,000 citations, clearly valuable work. I think there are 4 images of results in the whole paper, right? It's like a 25-page paper, right? So we've come a long way, sharing code, sharing data, sharing open metrics against that data. And it's been adopted and enamored by the research community and then the professional community, like you see here. One, it's well accepted. People understand what precision is, what recall is, what AUC is. We know what those measures mean. We don't have to worry about the model bias, right? There's new ones like Frenet inception distance and so on. There's model bias in that model that's being used to compute analysis on my classical measure. So how do I analyze that? So they're accepted, they're well understood. They're taught in classes and so on, right? That's what we, in my computer vision class and those of my peers as well, that's what we teach. It's what's accepted. Also, it's easy because code's available for it. And engineers, I'm a trained engineer as well, right? We're a little bit lazy. We don't want to always invent new things, right? So you can just download it and get it, right? So it's there. However, you can game, there's a big risk. It's one thing to do it in research where everyone's using data set A and computing metrics 1, 2, and 3. There you go. It's a fair comparison. it's a much bigger risk in practice to then go and get your data set, my data set from January 15th, and start to apply these measures on it, and then get these arbitrary absolute scores. Like, I need 80% precision before I can ship this model. 80% is meaningless for your data set, because you can game the data set. Like, as an engineer, you know this. This may be why, like, many of Voxel's customers, like, they have split teams, data team and like ML team. We talk to both of them. So we play the wall, like they throw the things over the wall, we can do the translation. But like, if you don't appreciate what's in your data set and you're just setting an arbitrary measure, 80%, 90%, whatever, it's kind of a meaningless number. And I think that's a big risk if you do it in practice. I don't know if you experienced something similar, Duncan.
Yeah, I was going to say the same thing, is that I think it is really good to move the industry forward. And it's a good check to be like, hey, am I moving in the right direction? But what I was really happy to see is that both the business metrics and the user satisfaction, because it's not just about how your model performs, it's how your model performs when it's interacting with the end user. And so, there can be things that have nothing to do with your model performance that could really affect your user satisfaction. Like, if you have a significant delay, we're talking about, you were mentioning earlier, what if your model's offline? What if you've got poor latency that actually really affects the user experience? Actually, to improve the user experience, it wouldn't be the best way to do it, wouldn't be to improve your model performance. It would be to reduce your latency between the end application and how you're serving your model. You might even decide you wanted to actually take your model, work on shrinking your model down and pushing it to be running on a chip locally so that the latency is much faster. That might be way more important for the user experience in deriving business value than it is for like, hey, did you get from 94 to 97% precision or recall, for example? I think it's useful, and I'd echo what Jason said, is those can be good metrics and a good place to start to know if you're moving in the right direction, but it's really the in situ, the context of how your model performs that I think is the most important.
And just to follow up on that briefly, I think it has been a delight to see, even minimally, but more than zero, papers in like the ML research community or like the CV research community that now actually have, like, even the existence of Frenet inception distance is this notion of like, will the user care about it, right? But it's not a user study. But we've even begun to see some human in the loop type analyses. Even my group has written some IRBs recently in the last few years. Like, what the heck is an IRB? This notion of like, well, the human matters, the user matters, right? So like, how do we build systems that will cooperate effectively in that case? Like, which is why like that DARPA project I mentioned, like, most of my research time now is being pushed in that direction, because I do think like the real problems are around like, how do these AI systems connect with the human users in a way, even if they're not personalized assistants, even if they're like general ones. Like, I think that connection is really interesting, really interesting.
Interesting and crucial to making a really good product, right? And I was concerned looking at this chart, noting that only 8.7% of respondents reported that they're measuring business metrics to measure success, because it doesn't agree with the user satisfaction chunk of that chart, does it? Like, if you're not looking at churn, for example, guess what? You aren't looking at user satisfaction. But these are domains that are sometimes separated. If, I'm sure like measuring customer churn is not something that is maybe covered in your computer vision course at University of Michigan, Jason. Maybe it is, I don't know. But it's like, this is a separate domain. We have folks who are extraordinarily technical, but I fear that maybe they don't always take the time, or I guess this report suggests they don't take the time to look at some of these business metrics. So is that an oversight in your view? Duncan, maybe do you want to go in on that one first?
No, I'd actually argue that it's a reflection of the maturity that I mentioned earlier, is that we're seeing that AI has moved more and more from research to practical application, and that we're spending more and more time on these problems as we're getting more and more models to production. So not only do we need to figure out the tooling for keeping models in production and performing well, but we need to start thinking about them more holistically. I work with Jerome, that Jason was mentioning before, our director of machine learning at Sama. We actually have dedicated human interaction researchers for when we're deploying our AI, because it's actually a really important aspect for you to consider from the beginning. And that's just in when we're using AI internally, let alone working with our customers who are developing their own AIs in so many different fields. So to me, it feels like a natural progression of maturity. So that's where I'm at.
Yeah, I would tend to agree. I think the ability to tie like business value to an AI system requires a significant investment in infrastructure. And we're only beginning to see like these visual AI or computer vision pieces make their way toward the end. Like if I had to, I would interview like UPS or FedEx, like they've been doing package sorting, or like even the USPS, like with computer vision type. It wasn't called that then, but it's like with pattern recognition systems for a long time now. Like how did they tie in business value or like, actual cost value into it? Like I think the business value I hear about most these days are very like to the maturity point, are very up in like the early side of it, right? Like, okay, we're going to invest K dollars in data in the next 6 months. How can we know that data has helped? Then basically like the existing benchmark scores are used. It's an unfortunate reality, but I think that's the business value is still tied into the early ML, almost like the ML echo chamber. What I'd expect to see in the coming years is like a better infrastructure to put like the data, the models at the heart of the world and tie business work right into it so that you can really understand the closed loop value.
Yeah, I'd love to see like that infrastructure that actually hooks into all of this. Business metrics is something that have been around for a long time. They're well understood in especially the traditional software space, like churn and other elements. This data actually exists, and we could be hooking that into our systems and actually looking at once you've got a model live and you want to maybe start A/B testing models, variants, when you want to start looking at what business impact it has. That's definitely a really exciting space for us in the future.
You're not going to believe this, Jason. I'm actually recording with the director of data science and machine learning from UPS next week or the following week. So you've just done my job for me. And now I know exactly what I'm going to ask her.
Awesome.
So tune in for that one. But we are creeping up on optimal podcast length here. And more importantly, the time that we have reserved for this. But I don't want to let you all go just yet. Moving out of the report, I wanted to ask the both of you to share a little bit of your career advice for the folks out there listening who want to continue forging a career in this space, being strategic and making huge, meaningful contributions at their companies. What sort of advice would you give them? Duncan, do you want to chime in first?
Sure. I would say the ability to speak multiple languages has always been an area that has been absolute huge value. And I don't mean, English to French. What I mean there is how do you having that technical skill set is absolutely amazing. And it's really, really valuable to understand technology, to be able to develop it yourself. But there's other hats that we've been talking about, whether it's the business metrics, how does that part of the business think about it? Whether it's about user research and design and aesthetics and interactions, getting yourself educated in those different languages and the way that you can understand the business impact of what AI is doing, that will help you rocket ship both the impact of your models, but as well as your particular career.
Awesome. Maybe I can have two mini ones. One is that we're talking about very technical ideas, like we talked about latent space and embeddings and like models. Like these are hard ideas, right? Like I've learned over the years that that's great, but just remember what we do in this field and in all fields really is by humans, for humans, and with humans. And I think if you miss that idea, that you will not achieve the potential, either your own potential or the group you're working with or the tool. I think remember human. The other bit would be similarly, like in this complicated space, these are really high dimensional ideas, like really reasoning about embeddings that are 2 to the 10th or whatever. Like that's not something humans are that good at. So I would recommend developing a muscle to try to predict, first of all, doubt, and then predict what's going to happen before you do the work. And then I think that ability to the muscle to like start to self-reflection about what you're doing through prediction, through your own generation, if you will pay its dividends in the future.
That is great advice. Remember human. What a great name for a podcast that would have been. What a missed opportunity. This has been that's fantastic advice from both of you. Thank you so much for sharing and for being here today and sharing your expertise with us. I think we are just wrapping up here. So at this point, I would just say thank you everyone for joining us. I've been Rob Stevenson. Duncan Curtis has been Duncan Curtis. Jason Corso has been Jason Corso. And all of you out there have been amazing, wonderful, talented data scientists, machine learning engineers, AI practitioners, what have you, however you came. We are so glad that you were here. Thanks for being with us here today. Have a great one. How AI Happens is brought to you by Sama. Sama provides accurate data for ambitious AI. specializing in image, video, and sensor data annotation and validation for machine learning algorithms in industries such as transportation, retail, e-commerce, media, medtech, robotics, and agriculture. For more information, head to sama.com.